Welcome. We are almost nearing the end of engineering mechanics, that is end of friction, that is end of ladder friction. Little few more questions. See, I am covering each and every type. 108. It is a pure exercise for you because it is same as last question, that is 107. Absolutely no change. But the cable used to prevent slipping. Last time, see, they asked you what horizontal push required here, P. Tension also is same way, T. Instead of P, it will be T. Make a note. Over. For the ladder of length 7 meters, see, length they are giving by words. This length is 7 meters. Shown in figure, see, this is a smooth wall, this is a rough surface, phi is 18 degrees. Shown in figure, find the maximum tension in the cable attached to the bottom of ladder if a man weighing 900 Newton safely goes through the ladder. Okay, that's the question. Some statement you have to write first. See, this is smooth wall. So what happens? Only RC. Here, RE, I'll take ABC, RA and mu RA. Okay. Somebody may ask, how you got 0.325? Sorry, no answer. Now if somebody will ask how you got 0.325, I can tell you are not studying anything. Okay, then. See, 350 they told, understood. This 350 is the weight of the ladder, understood. Or if you want words, I have given by words so many questions. This angle 48 degrees. See, using this 48 degrees, actually here not required, length is 7 meter, find the height and find the base length. Okay. So once you get a base length here, this is midpoint, you get the answer. Now, it is told, see you write here, let T be maximum tension. Let T be maximum tension. Maximum tension in cable. Now write. They want maximum tension. See, T will be maximum when the man ascending the ladder reaches the critical position. Critical position. Critical position when somebody is ascending the ladder, and he told the man weighing 900 Newton safely go through the ladder. He will start ascending from here and will go up to there, and then he will leave the ladder. So worst case is what? This is the critical position. That is when the man reaches exactly top of the ladder. I told earlier, top of the ladder. So that's why the man weight I put at the top. Here friction is not there. Okay, then that's all. Now see, now I should not tell anything. See, it's also told so many times. This way, your cable is here. Okay. Tension T, there also tension. But for the ladder, this tension is acting T. Now this question is exactly same as last time question. Last time P, this time T. Sigma Fx0 is there. Sigma Fy0 is there. Sigma M0, you write. See, minus RC into 5.202 plus 900 into 4.684 plus 350 into 2.342 equal to 0. By this time, you know the value of RC. See, you know the value of RC. Anything else is there? No. You know the value of RC. So then you substitute that RC here, and RA already you get the value of T. Class, T came positive. Means what? Yes, cable is required. By chance, even when you make a note here, suppose when the person reaches the top of the ladder, still limiting stage has not reached, then the cable is not required. It will be a wasted cable. It will be simply lying there. Your T will come negative. So negative value, if you get for T, you write no, not a negative value. Tension is not negative. Just you write what? That cable is not required. The man can safely go through the ladder only by virtue of the friction. Only by virtue of the friction. Extra help is not required. Okay. Question 108 over. Now 109 and 110. Two more questions of same type but different. Push upright, something will be there. Then one last question is there. That is an important concept-based question. Okay, first I'll go to 109. That also is somewhat like exercise only for you. Question 109. Next question. A ladder is placed as shown in figure. If you want by words, but actually this time I want ladder this side. So no words. Actually, how many times words I should give? I don't have to give words. See, understood. This is weight of ladder. 2.6 given, 3.1 given. Here friction is 0.15 coefficient. Here 0.1. Both are rough. Now, a man weighing 950 Newton. Remember, weight of man is 950 Newton. Ladder is 1.1 kilonewton. If you write 1.1 kilonewton, the weight you have to write 0.95 kilonewton. Be careful. Okay. Or if you want to write 950 here, you write 1100, then answer will come in Newton. Okay. Find a man weighing 950 Newton is ascending the ladder. Okay. Now see, now ABC is changed. Be careful. Don't by heart ABC. He is ascending the ladder. So the person who said the question, he thought this ladder is not stable. Reason why? See, little longer length here and low friction here. So dangerous ladder. Therefore, what he told somebody is, you bring a big weight and place it at the bottom of ladder. Exact bottom may not be possible. At the bottom, see, almost bottom, you place the weight, hang the weight there. Or theoretically at the bottom. Or they can ask you, instead of find the weight required, how much vertical push required. Both are same. See, if they ask you how much vertical downward push, understood. See, when ladder is slipping, you should push this way. How much vertical push is required? Instead of W, you write P. That's all. Okay. Find the least weight to be placed at the bottom of the ladder so that the man can safely go through the ladder. See, they want least weight. So ladder should be on the verge of slipping. Least weight required is 7.240. So therefore, if they want safety, they should place little higher weight. Okay. Least required is 7.240. Okay. Now, right. Let W be least weight to be placed at the bottom of ladder so that you write here what I told, so that see the man can safely go through the ladder. Then write. You have to place the person at the worst position. Worst position is when he stands at the top of the ladder. Unless in the question they told, suppose they tell the man want to reach only up to here, okay, then you can place him here. That is next question, last question. Last question, what I am doing is, I am placing the man here. This W, I am applying little upper side, so that moment it will come. Okay. So, understood, right here. The worst position is, the most dangerous situation is, when the person reaches top of the ladder. Place him there. That's all. Other things you write. Okay, start. Sigma Fx0 plus Ra minus 0.15 Rc0, equation 1. Sigma Fy0, start from unknown value, minus W plus 0.1 Ra plus Rc minus 0.95 minus 1.1 equals 0, equation number 2. Take moment about C, bottom of ladder. See, plus Ra into 3.1 plus, see, this is clockwise. Oh, this also is clockwise. This actually what happened is, it is a positive only, not negative. This answer is wrong. Because I was under the impression the wall was that side. It is this side now. Okay. See, if you take here, no problem. See, plus Ra into 3.1, again plus point. See, oh, no problem. I can make out. See, that's why I explain sometime. Plus what? 0.1 Ra. See, this is clockwise. This also clockwise. Plus 0.1 Ra into 2.6 minus 0.95 into 2.6 minus 1.1 into 1.30, you will get the value of Ra. Okay, Ra will change. I will change it. No problem. I will change it. What is there? Actually, I was under the impression friction was that side. See, usually when I write here, I thought it is that side. Usual habit is what? That top is there, anti-clockwise. Okay. That's why, anyway, such things happen. I can make out immediately. Okay, then 0.95 into 2.6 plus 1.1 into 1.3, that you divide by 3.1 plus 0.1 into 2.6. 1.161 kilonewton. It is 1.16. Suppose it is any calculation mistake is there, check the answer. Don't make issue of that one. RA will come 1.161. See, substitute in 1.161 divided by 0.15 RC. 1.161 divided by 0.15 is 7.74 kilonewton RC plus 7. That's all, 74 kilonewton. Next number is not there. Now substitute in 2. So W equal to 0.1 into RA 1.161 plus RC 7.74 minus 1.1 minus 0.95. 5.806 kilonewton. Okay. Plus 5.806 kilonewton. Sign important. Okay. Write a note there, class. Positive sign indicates that question is correct. Without this W, ladder is not stable. Suppose the ladder is already stable. See, friction is sufficient. If the man can reach there without any extra help, W will come negative. That's all. Okay. Now, last question, 110. Over. 110. Okay. This question I will write first and solve. This also, see, this also you make a note here. Previous question I told you, 109. This also somewhat exercise only. I told briefs in the class, in the title what I am writing is 3 exercise questions with the brief solution. Okay. Now, 110. This also exercise only. Exercise. A ladder is placed as shown in figure. Okay. I'll place the ladder now. I'll set the question. This way one now. Now this time this way. Okay. See. Now I'll give you smooth wall here. Y means once in a while smooth wall. Okay, better, rough wall only better because let the equation come bigger. Okay. This is the wall. See. Ladder should be little this way. Danger ladder. Okay, this way ladder. What I will do is I will give this length. Length of ladder I will give you. Length of ladder is say from 8 meter. A ladder, I will write here, ladder weighing something like a ladder weighing 80 kgs. Okay, 800 Newton per meter is placed as shown in figure. Okay. ABCD I am not giving. Now, I will tell here this bottom surface mu equal to 0.115, Here I will give mu equal to 0.114. Then I will give this angle now. This angle is a little steep angle, 40 degrees. Okay. Now, question can be given by words how a ladder 8 meter long weighing 800 Newton per meter is placed against a rough wall at an angle of 40 degree with the wall. That's all. Friction coefficient at the base for the ladder and ground is 0.18 and for ladder and wall is 0.14. Then this I will change now. I will change this question now. Then I will solve. See, now question. A man weighing how much I will put here? Some 800 kgs, not 800, 750 kgs. Okay, 750 Newton is ascending the ladder. and he wants to reach a point which is 1 meter, or not 1 meter, 1.2 meter height, which is 1.2 meter along the ladder from top. This is the question. Now, actually, if they ask in the question, he has to safely go through the ladder, place him here. But this time you have to place him at 1.2 meter from there. Okay, then, see now, find the least vertical push. Actually, okay, it's not okay, push, vertical push, no problem. It is actually not push. Okay, somewhat like a push only. Actually, vertical load. So, vertical push to be applied. Okay, you can call push, nothing to worry. To be applied to the ladder at a height of, see, that is not here. See, last time the W was here, now the upper side. See, actually, exact bottom, pushing is difficult. When someone will push here, he will slightly push upper side, little above. Okay. At a height of something like 0.8 meter, at 0.8 meter above bottom of ladder. Purpose why? To prevent the ladder, no, placed right here, to prevent the ladder from slipping. Okay, over. Okay, now this is a question. I will briefly solve first. I went there to break the video only, that's all. Okay, see now. First to do preliminary, right here, preliminary. Let P be the least vertical push. Now you continue. To be applied to the ladder at the given height to prevent the ladder from slipping. Okay, now, see, preliminary part first. Before that, least weight means ladder is on the verge of slipping. That all you know it. I don't want to waste more and more time now. Okay, this is the ladder. See, this length is given how much? Oh, ladder is this side. Oh, ladder is this side now. There. Oh, sorry. Okay. I'll ask two questions. Ladder is this side. Okay. Have it from that side. Okay. This is the ladder. Okay. So, this is 8 meter length of the ladder. Therefore, the weight of the ladder, W, will be equal to 800 Newton per meter for 8 meter into 6,400 Newton. That you have to calculate. You should write it. Weight is 800 Newton per meter, length is 8 meter, that's the weight. And then this angle is 40 degrees. If you use this 40 degrees, this distance will be 8 sin 40 and this will be 8 cos 40. And instead of 40 degrees, suppose use this angle 50 degrees, then this will be 8 into what? 8 into cos 50, that will be 8 into sin 50. This is told thousands of times earlier. If this you cannot do, I am helpless. 8 into sin 40. I can do 40 only, no problem for me. 5.142 meter. You have to calculate it. See, rounded. Height is 8 into cos 40. 6.128 meter. This is 6.128 meter. Calculated value. Okay, then if that is that much, this distance will be exactly half. 5.142 divided by 2 is 2.571 meter. Okay, now that person want to stand up, that person weighing how much? Weighing 750 Newton, want to reach this point. See, here. This is the position, that weight is 750. And they told, there is some small problem. This I can remove. Okay, this I can remove now. I'll shift the 8 meter here. See, this is 8 meter. Okay, up to there. 8 meter. They told this position, the person where he want to stand along the ladder. See, they told along the ladder at what distance? 1.2 meter from there. If that is 1.2, surely this will be how much? Up to here is 6.8 meter. Now, then the person standing here, 750 Newton, if I project that one, see, if I project that red color point, see, later I write here only, see, this distance will be, if this is 6.8, you can tell 6.8 into cos 50, cos 50, 6 or sin 40, 6 into cos 50. 4.371 meter. This all told for you. 371 meter. Show the calculation. Or you can do one thing. See, 6.8 out of 8. 6.8 out of 8 is how much? Into 5.142. 4.371 meter. Okay, over. Now, the vertical push is required here. See, here. How much P? P. Now, they told at the height, they told, see, this height. That height, they told, is you are not applying push at the bottom. The push is at what? 0.8 meter above, given in the question. 0.8 meter. If that is 0.8 meter, you require this distance. How to get it? See, this is 0.8 meter. See, this distance required. You correctly calculate this distance. I will not explain for you. This is told so many times here. You write this distance. I'll put a question mark. Okay. That much talent you should show. If this is height is 0.8 meter, you want this distance. First of all, I should not talk about these things. Okay. This now, as usual, remember, there's a normal reaction here, slipping this way, friction here equal to what? 0.18 times R. There's a normal reaction here, friction this way of what? 0.14 R. This all makes, see, this is exercise question. First of all, this much I should not explain, but still I almost explained everything. Okay, now I will draw a neat sketch there and then solve the question. See, just make a note, I am removing everything now. When you take moment about this point, see, you require P into this distance. So, height they told 0.8. So, this horizontal distance required. See, you can create a small triangle here, or you do what to see. I told so many options for you. Along the height 6.8 for 8 is how much here with respect to 5, how much total length is what was 5.142, that also will do. This is last. Okay. This is last actually. Okay. 5 point. Or you can use trigonometry and get it. These all need not be explained. Now we reach a stage where such things are easier. It's already explained earlier, see, in one class. So use your talent and get it. So that's why, see, the P I wrote here 0.671 meter. This is that question mark. Okay. Now, nothing required. I will remove the full board. Now, I written the free body, see everything entered here. Remember, this 0.671 and 4.371 are calculated value. This is where the man is standing horizontally from here. Actually, they told this distance, we got this distance, and then we got this distance. Here, they told the height, because of that height 0.8 meter, this you got 0.671 meter. This already explained. Okay, now nothing is there. Sigma fx0, first of all, exercise question. Plus 0.18 RA minus RC 0, equation 1. Sigma fy 0, start from unknown. Which one unknown? Okay, plus RA minus P, anything you can write first. Plus RA minus P plus 0.14 RC minus these two forces equal to 0. Equation number 2, take moment about this point A, minus RC into 6.128 minus 0.14 RC into 5.142 plus P into 0.671 plus 6400 into 2.571 plus 750 into 4.371 equals 0. You 1, 2, 3. See, this time you have to solve. This is not a mathematical trick. See, RA, RC, RA, RC, P. RA is not there, 2 RC are there, and P is there. If you use directly using calculator, go to equation mode, you decide an order. See, for example, if your order is RA, then RC and P, you enter the coefficient 0.18 minus 1, 0, constant 0. Second equation, 1, 0.14 minus 1, take that side, plus 6400 plus 750, equation number 2 here. RA is not there. So 0, RA 0, minus 0.6 RC for RC, minus 6.128 minus 0.14 into 5.142 RC coefficient P plus 0.671. These two, take that side with minus sign, solve. Then X will be RA, Y will be RC. Go further. X and Y not required. Continue. Your Z will be P. 20959.241 Newton. Or if somebody wants to systematically calculate, then do one thing. See here. Or, see, our purpose is to find P value, correct? See, you should remember. Purpose is to find P. See here. RA, RC, P. RA is not there. RCP. Here. RA, RC. So, from equation 1, you eliminate RA. How much RA equal to? RC by 0.18. Substitute that in equation 2, where RA comes, right? RC by 0.18. Simplify. What will happen? In terms of RC and P, you get one equation. Say equation number 4. And equation 3 is already in terms of RC and P. See here. So use 4 and 3 and get the value of P. Solve that way also. We'll check the answer now. If you solve that way, people will start laughing now. 20959 plus 20959.241 Newton. Okay, this answer. Now 1 minute. I did this carefully in the calculator. So 99% this answer is correct. So then this also is correct. By chance, see this side not calculated, I saw there. By chance, if any entry in the calculator is wrong, if answer is different, you get this answer, then the same answer will come here. So again, don't comment, answer is wrong. You tell procedure wrong or concept wrong. The explanation is wrong. That way you should tell. Or you can comment, this person does not know how to explain. One person commented long back. It is sheer out of jealousy, that's all. Out of jealousy only it is commented. If somebody commented, I crystal centroid, I crystal clear explained with the model, he is telling some nonsense things he is telling. Something nonsense you are telling. Some books you referred, where the person in the book wrote nonsense, he is reading that one. Okay. Therefore solve it. Over now. 110 over. Now, I need just one more class for friction, where not only lateral friction, another 2 questions will be there. That is a question, special question. See, in all the questions so far, we considered reaction and friction force. Sometime in examination, they will ask you, what is the forces acting on the surface? Answer is very simple. Find the reaction, reverse it and apply. That's all. So I will make a note for you. You should be careful. But at that time, if limiting is not given, friction is not proportional to normal reaction. So those questions, last class, question number 110 over, 111, 112, 113, single class, I will finish it. So today is Thursday, tomorrow Friday, this is uploaded Friday, Saturday we'll have a class. Then I will take 2 days break because I am changing over to strength of materials. Not for preparing. I have to arrange the chapters first of all. I should see what, I have to prepare thumbnail also. See, for uploading, I require thumbnail. And I have to upload one more class. Explaining the course, I have to explain. And little more I want to talk. Because I have to warn everybody that we are entering the most critical part of structural engineering. Therefore, one more class for friction, what all done in engineering mechanics, today's class and next class, including everything. Total number of classes for engineering mechanics, I think, would have been more than around 350, I think. I first thought it may be 250, 300. See, it has gone further. Questions also, friction, see, 110. You can see every pair in parts. Question number was exceeding 100. In centroid moment of inertia, it was much. Center of gravity separate, then moment of inertia only crossed 100. See there? That is more than 150, 160 questions there. Nowhere you can find this much solution. And that too, very important, without any technical mistake. Okay, now I'll conclude the class. Next class is the last class for friction. Thank you. Next class we'll meet.